morning, everyone. My name is Ivy, and my topic is the Humboldt Penguin, Spheniscus, humboldti, Rete Tibiotarsale, a supreme biological heat exchanger. And these are the authors. This is the Humboldt Penguin. It is a medium-sized penguin, and it grows to 56 to 70 centimeters long and weight around 3.6 to 5.9 kilograms. It has a white border around its face that makes us more easy to recognize it. And the distribution of the Humboldt penguin is around the coast of Chile and Peru. And because the Humboldt penguin's physical data is relative detailed than other penguins, so they also choose this penguin to study. My purpose is to tell you that the Rete Tibiotarsale, I will call it RT later, is important to penguin. What is RT? You can look at this picture. This is Humboldt penguin's foot. The arrow is the flowing way of the blood. The artery brings the warm blood from heart to the foot and near the cold environment. And the cold blood will flow back to the vein. The tangled part of the arteries and vein is the artery, and it is a heat exchanger. The cold blood will be warmed up in this part, so the cold blood will not flow back to the heart directly, and the penguin can save the heat in the cold environment. Why do penguins need the RT? In this study, McCarthy and his crew used thermal camera to observe the emperor penguin. And the lowest temperature of the foot is -18 degrees Celsius. And because the environment of the penguin live is very cold and they step directly on the ice, so they need RT to help them to save the heat. And let's talk about the method. This is a simulating study. And first, we gather footage data of Humboldt penguin from the Humboldt Zoo in Israel. You can look at this chart. This is the measure standards. Second, we use these data to build a penguin foot model like this. This is a simple one model. And third, we consider with the foot arteries and veins to have a better model. Fourth, we also build a humankind penguin foot model like this to compare with the actual one. And last, we consider with the environment and physical factors like temperature, wind speed, heat diffusion, metabolic rate, and blood flow rate. And heat diffusion means the heat goes away from the living bodies. And metabolic means the sum of the physical and chemical process in the living body. And if you don't know what I'm talking about, we call it 新陈代谢 in Chinese. We consider these features and model and put it into the console. It is a simulated software. Excel, MATLAB, and some equations to get the result. And let us analyze the results. The author compare with the human-like leg model with the actual one. A human-like leg model didn't have the RT, so the cold blood will not be warmed up before it flows back to the heart. And this kind of leg model will lose more heat than this kind. red light is the body core blood temperature. And this is the temperature of the human heart. And this is the temperature of human leg tissue. This is the arteries, the temperature of arteries in penguin. And this is the temperature of veins in penguin. The temperature differences of the heart and human leg tissue is 3 degrees Celsius, and their distance is 0.5 meter. And the ratio of delta T to delta X is 6 degrees Celsius per meter. And in penguin case, the temperature difference of the arteries and veins is 10 degrees Celsius, and their distance is 0.005 meters. The ratio of delta T to delta X is 20,000 degrees Celsius per meter. So with these two numbers, we can know that the penguin RT is more efficient on heat exchange. And this is the temperature distribution of the penguin leg model. This is the Humboldt Penguin leg model, and this is the human-like penguin leg model. In the condition of when the blood of temperature which fall into the arteries is 38 degrees Celsius, and it becomes 1 degree Celsius after it falls into the veins. The penguin leg model remains 20.35 watts with the RT, while the human leg only 9.05 watts. The watt means the efficiency of energy transport. So the RT is more efficient on heat exchange. And please look at this picture. The y-axis is the temperature of the blood which flows into the veins, and the y-axis is the efficiency discrepancy factor. It is the calculation about the metabolic heat conservation of the penguin and human. So we can know the metabolic heat of the penguin cell than the human. We can know how much the metabolic heat can penguin save than the human if the penguin have RT to help them save the heat. And in these conditions, when the blood which flows into the arteries is 38 degrees Celsius, and it becomes 1 degree Celsius after it flows out the arteries, the inlet temperature difference is 37 degrees, and this is out. And the efficiency discrepancy will be 65%. And in this condition, when the temperature of blood which flows into the arteries is 25 degrees Celsius, and it becomes 10 degrees Celsius after it flows out the arteries. The inlet temperature difference is 15 degrees Celsius, and the efficiency discrepancy factor is 25%. So we can know that the inlet temperature difference is higher, the efficiency discrepancy factor will be higher too, and the penguin can save more metabolic heat metabolic heat than the human. It also shows us that the penguin RT can contribute to 25% to 65% metabolic heat conservation. And this is the other penguin leg model. In this part, the red spot is the artery. It means the higher temperature. And in this part, The blue spot means the vent temperature. It is a low temperature. So the heat exchange is in the cross part of the reed. And the RT thermally isolates the fluid from the particle quite well. And the next part is my conclusions. First, RT is more efficient on heat exchange and help to keep more heat. Second, the Penguin RT can contribute to 25 to 65% metabolic heat conservation. Third, the RT thermally isolates the fluid from the particle quite well. And the last, the most important one, the Rete Tibiotarsale is important to penguin. And thank you.
Okay, good.